Hello PLP Geometry, welcome to the first video in Unit 4. This will by far be my favorite unit. It gets off to kind of a slower start, but then again it really takes off here. So Unit 4 is titled Similarity and Right Triangle. When we get into the right triangles, that's where I really enjoy this class the most. Okay, so we will start with our first section here on what are called dilations. Dilations. So dilations is actually a transformation. It's the last of 4 transformations. We just didn't talk about it when we came to reflections, translations, rotations, because dilations are not rigid motions. We'll talk about that as we go through. Okay, so what in the world is a dilation? So a dilation. So a dilation is a transformation that has a center of dilation C and a scale factor N. So dilation is a transformation that is a center of dilation C and a scale factor N. Now, there's a lot more to it. That's just where I started. That's where I wanted to start. Okay, so let's draw a triangle. So let's draw, it's going to be a smaller triangle. Okay, and let's call this triangle X, Y, Z. Okay, and then I'm going to put a point C right over here. I'm going to scoot it back just a smidge. Okay, so here is my point C. So this is the setup. Okay, so what I'm going to do is I'm going to draw a triangle that is the same shape as triangle XYZ, but I'm going to enlarge it. And I'm going to enlarge it twice as big. And here's how I'm going to do it. So if I connect, and I'll use green, if I connect C to X, I'm going to double that distance and continue this segment. There's X prime. If I connect C to Y, I'm going to double that distance. There's Y prime. If I connect C to Z, I'm going to double that distance. And there's Z prime. And if I connect these 3 points, 1, 2, 3, there is my dilated figure. Okay, so a dilation, right, is this idea of taking an original preimage and either making it enlarge or reduce. Okay, now a couple of things hold, actually several things hold that we're going to list out right over here on the side. Okay, I'm going to change color to blue. Okay, so number 1, your correspondence, right? So X corresponds to X prime, Y corresponds to Y prime, Z corresponds to Z prime. Notice that they're collinear, right, with the center of dilation. So collinear means on the same line. So I can draw a line between the center of dilation C, X, and X prime. Okay. So there's the correspondence. So angle X will be congruent to angle X prime. So in the pre-image, the angle at X is the same measure as in the image with X prime. And it's the same for all the other ones too. I'm not going to mark them all. Okay. Also, segment XY or side XY will be parallel to side X prime, Y prime. Not double prime, just prime. So if you look at this picture here, and again, this is a big idea when it comes to dilations, is that xy and x prime y prime will be parallel. They will not touch. These two ideas put together mean that your preimage and image are the same shape. Same shape. Okay, so now let's talk about the scale factor. So I'm going to erase this. Please keep adding it on. I'm going to erase it so I have space. So now, what else is true in terms of the scale factor? And again, we're going to let n be the scale factor. I wish I could erase faster, sorry. Okay, that's the best I'm going to do. So now let's talk about the scale factor n. So when it comes to the scale factor, okay, if I want to find the distance between my center of dilation and the image x prime, I would take the scale factor n and multiply it by the original distance from my center of dilation and the preimage x. So this is true for any vertex and the center of dilation. Now, I can also do it for the side lengths. If I want to find the length of x prime, y prime, the new side length, I take the scale factor and multiply it by the old original side length, xy. These two ideas mean that your figures will be different sizes. Different size. And last but not least, if we talk about the scale factor, if I want to find the scale factor n, I'll do it back in red. If I want to find the scale factor, I always take the image length, and I divide it by the pre-image length. So it's always the image over the pre-image. So that's an interesting idea when it comes to finding the scale factor. Now, when we talk about scale factors and enlargements versus reductions, if your scale factor n is greater than 1, then you are going to enlarge your preimage. Enlargement. But if your scale factor is less than 1, now, has to be positive, so really it's in between 0 and 1, but I'm not going to confuse you with the 0. So if it's less than 1, but positive, right, then your figure is going to get smaller. It's going to do a reduction. So those are the two different types of dilations you will see. Enlargement, reduction based off the scale factor value. Okay, so let's take a look at a couple examples, and then we'll talk about the coordinate plane. All right, so let's set this up. Okay, so our first example here is I want you to find the lengths of the image. Find the lengths of triangle A prime, B prime, C prime. Okay, so here is going to be triangle ABC. I'm going to make it a right triangle just for ease. A is up here, B is the right angle, and C is here. I'm giving you that these sides are 3, 4, and 5 in length. And I'm going to give you the scale factor, our scale factor, which is n, is going to be equal to 3. Okay, so what I want to do is I want to find the side lengths of the new figure. So what's going to happen here is because n is greater than 1, we are going to enlarge. So to find A prime, B prime, I'm going to take my scale factor of 3 and multiply it by AB. So I'm going to take 3 and multiply it by 4. And 3 times 4 is 12. To get the length of B prime, C prime, I'm going to take my scale factor of 3 and multiply it by BC. That would be 3 times 3, which is 9. And if I want to find the length of A prime C prime, I will take my scale factor of 3 and multiply it by AC. That's 3 times 5, which is 15. And there would be the 3 side lengths. So if I want to draw that picture real fast, I'm just going to draw a bigger triangle, a bigger right triangle, right? Looking the same as that one, right? Here is A prime, B prime, C prime in corresponding position. There's that right angle. And again, the length of A prime, B prime would be 12. The length of B prime, C prime, 9. And the length of A prime, C prime would be 15. And there you go. So again, scale factor bigger than 1 is going to enlarge. Okay, let's do a second example. All right. So example here. It says, now we're going to find the scale factor. Find the scale factor. Okay, so for this problem, I'm going to give you two triangles. Again, they're going to be right triangles. Again, just for simplicity's sake. So I have a triangle here. We're going to call this X, Y, and we'll make Z the right angle. XZ is 15, XY is 39, and YZ is 36. And then I have a second triangle down here. Just a sec, make it a little smaller, just for somewhat of scale. Okay. Another right triangle, let's call this X prime, Y prime, Z prime. And we have 5, 12, and 13. Right? And I would like to find the scale factor between these two triangles. Okay, so we're going to find the scale factor going from triangle X, Y, Z to triangle X prime, Y prime, Z prime. So to find my scale factor n, I'm going to take a length from the image, any length at all, and divide it by the length from the pre-image. It doesn't matter which one. I'm actually going to do xz. So I'm going to do x prime z prime over xz. So x prime z prime is 5. xz is 15. If I divide those, I'm going to get a decimal that repeats, 0.3 repeated. So I would appreciate if you wrote the fraction, and that fraction is 1/3. For this problem, going from triangle XYZ to x prime, y prime, z prime, the scale factor is 1/3. Now I hope that's not a surprise to you, because again, 1/3 is less than 1. That means that this is a reduction. And if you look at your pre-image, XYZ, to your image, X prime, Y prime, Z prime, you went from big to small. Okay? All right, last thing I need to show you guys is dilations in the coordinate plane. All right, so let's do dilations on the coordinate plane. Perfect. Okay, so for a scale factor of n with center of dilation the origin, with the origin as the center of dilation, x comma y is going to become n times x, n times y. That's it, right here. So these are times dots. Hopefully you can see they're times dots, not subtraction. So again, long story short, you just multiply. Okay, so let's do one for each type. Let's do an enlargement and a reduction. So let me draw this coordinate plane here. This is the origin. Let's put point xy right there. So there's the point xy. Okay? Let's say that our scale factor is bigger than 1, which means it's going to be an enlargement. So what's going to happen here is if I connect the origin to our point, we are going to get farther away from the origin along this line. So again, for simplicity's sake, if I just think of n as 2, if I double it, there would be where the new point ends up. And the coordinates of that point would be n times x, n times y. So for this one, for an enlargement, we're getting farther, so farther from origin. Okay, now over here, let's do a similar thing. I'll put my origin here. I'll put my point xy sort of in the same spot. Okay, this time though, let's do a scale factor less than 1. So let's do a reduction. So now when I multiply my coordinates of x and y, they are still going to be along this dotted segment between the origin and the original point. But let's say the scale factor is a half. Now we're going to go only a half as far. So now my point would be right here. Let me do it in purple so you can see. That point would be right here at nx and y. At nx and y. And in this case, because the scale factor is less than 1, we got closer to the origin. So I'll put it right here, closer to origin. So we're going to love doing things like the coordinate plane because all we do is we multiply. Okay, thanks for watching. Good luck on your practice.